Okay, let us look at another example. A rod 8 meters long. So let me take note of that. The length of the rod is 8 meters. It has a linear density that is a linear function. So let me write that. A linear function is a function of the form ax plus b. All right. Now, if the linear density on one end is 6 kilograms meter, that means that at x equal to 0, rho of 0 is equal to 6. That's what this line is telling us. Another information that is given is that on the other end of the linear density is 3 kilograms. So at the other end, that is the end at x equal to a, the linear density is given by 3 kilograms per meter. Now with this information, let's try to find the values of a and b so we can have our linear density. So at rho equal to 0, our function is a times 0 plus b. So rho at 0 is just b. And from here, we know that the linear density at 0 is 6. So we have the first value, b is equal to 6. Next, at x equal to 8, rho of 8 is 3. So now, let's write that here. Rho of 8, substituting x equal to 8 here. So we have 8a plus b. But we already know what is b. It's 6 from here. So this is 8a plus 6. And another information that we know, rho of 8 from here is equal to 3. So from here, we can solve for a. 8a is equal to negative 3. So a is negative 3/8. Thus, we can now conclude that our linear density rho of x, which is a linear function, is a, that's negative 3/8, x plus b, which is 6. Now to find the center of mass, it's actually the problem. Finding the center of mass, we need to find the moment of mass. So let us start there. So the moment of mass is given by the integral from 0 to L. The length is 8. X times the linear density, which is negative 3/8x plus 6 dx. And then multiplying, I have negative 3/8x squared plus 6x dx. The antiderivative is negative 3/8 times x cubed over 3 plus 6x squared over 2. Evaluate from 0 to 8. Let us simplify first here. First, I have a 3. And then here, 6 divided by 2 is 3. Therefore, we have negative x cubed over 8 plus 3x squared. Evaluate from 0 to 8. Now, we're ready to evaluate. When x is 8, we have 8, and we have an 8 in the denominator, so I will have a negative 64 plus 8 times 8, that's 64 times 3. So 64 times 3 is 192. So the moment of mass is 192 minus 64. That gives us 128 kilograms meter. That's our moment of mass. Now let us look at the mass of the rod. The mass of the rod is integral from 0 to 8 of the linear density, which is negative 3/8 x plus 6 dx. Antiderivative, we have negative 3/8 times x squared over 2 plus 6x, evaluate from 0 to 8. Let's see if there is something we can do here to simplify. I think there is none, so let me proceed. So I will have here negative 3x squared over 16 plus 6x, evaluate from 0 to 8. So when x is 8, so 64 divided by 16, we have 4 times 3, so I'll have a negative 12 here, plus 48. So the mass is 36 kilograms. And finally, the center of mass is equal to the moment of mass divided by the mass, which is 36 kilograms. So therefore, how much do we get? Both divisible by 4. How about 9? Okay, divisible by 4. So 128 divided by 4 is 32. And 36 divided by 9 is 36 divided by 4 is 9. So the center of mass is at 32 over 9 meters. That's it. Good night, everyone.